Hello everyone. Today I am going to start optimization by MODI method, modified distribution method or UV method. We can call this one as UV method or MODI method or modified distribution method. Very important method. Now to find this optimum solution, first of all, we need IBFS solution. They'll give you one transportation problem. Find the optimal solution. They will ask like this, or solve the TP optimally. To find the optimum solution, first of all, we need IBFS solution. That may be in any one of the northwest corner rule or least cost method or WAM, Vogel's approximation method. But out of these three methods, WAM, Vogel's approximation method is very much preferable. Why? Because while doing in WAM method, Vogel's approximation method, you will get minimum transportation cost comparatively with least cost method and northwest corner rule. That's why always I prefer doing Vogel's approximation method. Now here one problem is given. Solve the TP optimally they are asking. Now to solve this optimally, first I will solve this problem. I will find the IBFS using Vogel's approximation method. Already we know how to solve. That's why I will write the occupied cells and the total cost only I will write, and then I will start the optimum solution problem. Now if you want, you can solve in your own. It will take some time. That's why just I am writing the occupied cells and the total cost using Vogel's approximation method. If you want to learn the Vogel's approximation method, just see the previous video. Now optimization by MODI method we are doing. Now this TP by using WAM, I find the IBFS using WAM. I have got these many 6 occupied cells, and by using WAM, if I find, I have got the total transportation cost. Total cost is equal to rupees 781 rupees I have got. Now I am starting the procedure of optimal solution. To find the optimum solution, first of all, like this, you have to find the IBFS solution using WAM or any of the method, preferably WAM. Now after getting the solution like this, now you have to write here U1 is equal to U2 is equal to U3 is equal to, and here V1 is equal to V2 is equal to V3 is equal to V4 is equal to 4 rows. U1, U2, U3 represents rows. V1, V2, V3, V4 represents columns. Now for occupied cells, we have one formula for occupied cells. We have the formula Ui plus Vj is equal to Cij. Ui plus Vj is equal to Cij is our formula for occupied cell. How many occupied cells are there? 6 occupied cells are there. This one, 6 occupied cells. For these occupied cells, using this formula, we have to find all the U1, U2, U3 using this formula. All the U1, U2, U3, V1, V2, V3, V4 values we have to find. To find all the values, let us assume any one of the value is equal to 0. Out of U1, U2, U3, V1, V2, V3, V4, any one value, take it as 0, because to find the remaining values, let us assume that U1 is equal to 0. Using all these values, using this value, we can find the remaining values. Now occupied cell is here, occupied cell. The place value is occupied cell. This is the occupied cell. The place of this occupied cell is first row, second column. First row U1 plus V2 is equal to C12. Ui plus Vj is equal to Cij. U1 plus V2 is equal to C12. U1, how much is U1? U1 is 0 plus V2 we don't know. C12, cost matrix element C12. This is the C12. C12 place is first row, second column. Cost matrix element is 8 is equal to 8, implies V2 is equal to 8. In the same way, second occupied cell is this one. This one is in the first row, fourth column. First row, U1 plus V4 is equal to C14 is equal to U1 is 0, V4 is equal to C14 value is 5, implies V4 is equal to 5. In the same way, the remaining also we can find U2 plus V1 is equal to C21, that is equal to do you know U2? We don't know U2, we will find later. And next occupied is U2 plus V3. Do you know U2? We don't know. We will find C23. U3 plus V2 is equal to C32. Do you know V2 value? We know V2 value. U3 plus V2 is 8 is equal to C32. C32 is 9. C32. 32. Second row. Third row, second column, implies U3 is equal to 9 minus 8 is 1. U3 is 1. V2 is 8. U1 is 0. In the same way, we will find the remaining also. U3 plus V3 is equal to U3 plus V3 is equal to C33. U3 is equal to 1 plus V3 is V3 is equal to 7, implies V3 is equal to 7 minus 1 is equal to 6. Using all these values, we can find the remaining also. U2 is like this. Using this formula, Ui plus Vj is equal to Cij. By taking any one of the value, U1 is equal to 0, you have to find all the values U1, U2, U3, V1, V2, V3, V4. After that, we have to find the unoccupied cell values. For unoccupied cells, the formula is Pij is equal to Ui plus Vj minus Cij. This is the formula for unoccupied cells. How many unoccupied cells are there? Here the place value is unoccupied cell place value is first row, first column. This one is first row, third column. And this one is second row, second column, like that. First I will write P11 is equal to P13. Next P22. P24, next P31, P34, third row, fourth column, P11, U1 plus V1 minus C11, P13, P13 means U1 plus V3 minus C13, U2 plus V2 minus C22, P24, U2 plus V4 minus C24, U3 plus V1 minus C31, U3 plus V4 minus C34. Now that is equal to we will substitute all the values. U1 is how much? How much is U1? Zero plus 2 minus 6, C11. What is C11? C11 is a cost matrix element 6 is equal to minus 4. 0 plus 6. C13 is 8. C13 8. C13 place is 8 is minus 2. That is equal to 3 plus 8 minus 11 is equal to 0. 3 plus 5 minus 7 is equal to 1. 1 plus 2 minus 8 is equal to minus 5. 1 plus 5 minus 13 is equal to minus 7. Like this, all the values you have to find. C11 means cost matrix element for unoccupied cells. These and all for unoccupied cells. After finding all these values, if you get all the Pij values, are less than or equal to 0, then our solution is optimal. Then we can write the solution is optimal. Therefore, the answer is, therefore the total cost is 8 into 5 plus occupied, wherever occupied is there, you can write that is as our answer. But we did not get all are negative. We did not get all are negative. Negative or 0, less than or equal to 0. If you get all the Pij's less than or equal to 0, then we say that it is the optimum solution. But we did not get like that. Here one positive value is there. Here one or more than one positive value, if is there any occurs, then if only one occurs, take that value. If more than one occurs, the maximum positive value, the highest positive value you have to take. One or more than one positive values occurs, the highest positive value you have to take. Here one I have got only one, that's why one I took. The place value is P24. It is there in P24. Now it is there in P24. Second row, fourth column. Put one dot here, P24. In near P24 only I have got positive value. Wherever you have got positive value, put one dot here. From here, what is the meaning of that? From here we have to start the closed loop. What is mean by closed loop? It will start from one place to and roaming here and there and somewhere, and again it ends in the same point. If ends in the same point, then we say that it is formed a closed loop. Now to form a closed loop, we have few rules are there. Now from one point, from here it is starting from 7. To form a closed loop, to turn, see from here to here, it comes like this, and here occupied cell is there. Wherever occupied cell is there, then only closed loop can take turn. Here occupied cell is there, that's why we can take turn. Here there is no occupied cell, that's why we cannot stay here, and we can jump from here to here like this. Now from here starting point is here. We have to start. Why this place only? Why not the remaining place? In this place in P24, we have got the positive value, the highest positive value or only one positive value. That's why I am starting from here. From here to, it will go like this. Here occupied cell is there. That's why it is taking turn. To take turn the closed loop, to take turn the loop, there must be a occupied cell. Now here there is no occupied cell, we cannot stay. From here to here, again it come. Here occupied is there, that's why again here we can't take, here we can't stay here. That's why from here to here occupied is there. That's why I came here. From here to here, from here to here, from here to from here to here. Again from here occupied is there, we can take turn. From here to here, again from here to the starting place. See the the closed loop, from here it is started. Here occupied is there, that's why we came here and we stayed. And from here to here, because here occupied is there. From here to here there is no occupied, that's why we cannot stay and we cannot take turn. That's why here, from here to here, from here to here, here occupied is there, we can take turn. From here also occupied is there, we can take turn. Like this we have to form a closed loop. That may be, the closed loop may be rectangle shape or square shape or L shape or reverse L shape, whatever it may be. It is in this form. Now wherever starting point is there, in near starting point it is plus. Now in the wherever occupied is there, alternatively plus and minus. Starting point always plus, wherever occupied cell is there in this direction only. Now alternatively plus and minus, you have to go plus, minus, plus, minus, plus, minus, again plus, starting point. Now starting with the plus 2, alternatively you have to put plus and minus wherever occupied is there near the closed loop. Plus, minus, plus, minus, plus, minus, again plus. It is like a closed loop. Here in this closed loop, how many plus symbols are there? How many minus symbols are there? How many plus symbols are there? 1, 2, 3 plus symbols, 3 minus symbols. Minus, minus, minus. Now out of the, just observe the minus symbols. Minus, minus, minus. 3 minuses are, minus symbols are there. See the occupied value in these 3 minus symbols. Here 23, here 5, here 25. Occupied values are 23, 5 and 25. Out of these 3 occupied values, which one is most minimum? Minimum is 5. That means we are transferring 5 units from negative cell to positive cell. We have to transfer, what is the meaning of this? We have to transfer 5 units from negative cell to positive cell. And we have to transfer, and we have to draw new table. Now we will transfer 5 units from negative cell to positive cells. Here 23 is there. From this 23 I am transferring 5 units to the next cell. Here, from here, if you send 5 units to here, remaining is 18. Here you will get 18. Here 27 plus 5 will become 32. Now from here to here negative cell is there. From here to here I am sending 5 units. Here nothing will get. Here only 5 will get. Now from negative cell to positive cell. From here to here I am sending 5 units. So that here remaining is 25 is there. If you send 5, 20. Here you will get 5 plus 5, 10. From here to here 5 units I send 5 units. That's why here 10. Here 20. From here to here, negative to positive, I send 5 units. Here nothing, here 5, here 18 and here 32. Here 5 and 32. The another one is the last one 35. I did not touch this one. I will write as it is. 1, 2, 3, 4, 5, 6. Now like this I formed a closed loop. Here the solution is not optimal because one positive value we have got. The solution is not optimal. The solution is not optimal means again the same thing. U1, U2, U3 values you need to calculate, and V1, V2, V3, V4 values just like the previous one you have to calculate using the formula for occupied cells and unoccupied cells. Now how to calculate? Again I will tell you. For occupied cells, the formula is Ui plus Vj is equal to Cij. Now any one value, let us assume that U1 is equal to 0. Any one value we have to take it as 0. Let us assume. To find the remaining values we have to assume. That's why I took U1 is equal to 0, and I will find U1 is equal to 0. Now using this cell I will tell you. U1 plus occupied cells. For occupied is U1 plus V2 is equal to C12. U1 second place, first row, second column is equal to in the same way U2 plus V1 is equal to occupied value C21. U2 plus V4 is equal to C24. U3 plus V2 is equal to C32. U3 plus V3 is equal to C33. Like this values you will get. Now using all these formulas, if you find U1, U2, U3, U4 values, we will get. Now if you find all the values like this, you will get V2 is equal to 8, V4 is equal to 5, V1 is equal to 3, U2 is equal to 2, U3 is equal to 1, V3 is equal to 6. Like this we will get. I wrote all the values U1, U2, U3, V1, V2, V3, V4. After transferring few units we have got like this. Now in the new box I wrote all these things, and in the same way for unoccupied cells also we have to calculate. For unoccupied cells, formula is Pij is equal to Ui plus Vj minus Cij. For unoccupied cells, wherever unoccupied cells are there, using the unoccupied cells, wherever P11 in the first place, first column, first row, first column we have unoccupied, P13, next P22, P23, P31, third row, first column, P34. U1 plus V1 minus C11, U1 plus V3 minus C13, U2 plus V2 minus C22, U2 plus V3 minus C23, U3 plus V1 minus C31, U3 plus V4 C34, U3 plus V4 minus C34. Using the formula we have to substitute all the U1, U2, U3, U4, V1, V2, V3 all the values, and C11 cost matrix value, and you have to U1 is 0 plus V1 3 minus C11 is 6 is equal to how much you will get? If you find all the values by substituting U1, U2, U3, V1, V2, V3, V4 values, and you will get like this. If you observe all the values of Pij, all are, we have got negative, minus 3, minus 2, minus 1, minus 1, minus 4, minus 1. All Pij's less than or equal to 0. Therefore, the solution is optimal. We reached optimal solution. We stop iterations. Now, therefore, the total cost is equal to, therefore, total cost is equal to here 8 into 10 plus 5 into 20 plus 5 into 35 plus 7 into 5, 8 into 10, 5 into 20, 5 into 35, 7 into 5, 9 into 18 plus 9 into 18 plus 7 into 32. 8 into 10 plus 5 into 20 plus 5 into 35 plus 7 into 5 plus 8 9 into 18 plus 7 into 32 is equal to how much we will get? If you simplify, we will get 700 and rupees 776. Like this you have to find the 776. Now in VAM we have got 781. Optimum solution is 781. Then that one little bit less value only you have got. This is the optimal solution. Like this you have to find. Thank you.